coroutine dot create, and this will create a coroutine. And as you can see here, it says it takes in a function. So basically in here you have two things you can do. You can either create your own anonymous function and put it in here, or you can create a function, put it in a variable, and then stick it in here. We'll do both just to show you the differences. Anyhow, so we can say function, and in this function we can just create a basic for loop, and let's say this for loop will return the values 1 up until 10, and it will print out the value. So it's just a basic for loop, there's nothing special about it. Now here is where the special part comes in. So we say if I is equal, and let's say 5, so right in the middle, then we want to actually stop the coroutine from finishing. We want it to wait. We can then say coroutine dot wait dot wait. No, that should be coroutine dot yield. And this will yield the coroutine. It will make it wait before continuing. And you'll actually see what it does in a second. Let's just actually code it first so we know what's going on. Next up, we can create another routine, and this can be called routine 2. And here, I'm just going to create a function just to show you the two different ways you can do it. You can create a normal function, but I'm just going to store the function because why not? And we can call this routine find, so for routine function, and that can be equal to a function, and here we can say for, and then we can say I is equal to, and let's say we wanted to continue counting, so we can make that 11 all the way until 20, and here we can say print, and this is routine 2, so I'm just going to say routine 2, and then we can just say here I, and we can actually make that routine 1 just so we can easily see the difference between them. So instead of just that, we can say that, and we can just make that routine 1. Now routine 2, we can make that equal to coroutine, coroutine, and dot create. As soon as it takes a function, we can just say routine. And there we go. That should be all we need. Now down here, we can actually get the status of a routine. So before we actually execute a routine, let's get the status of it. So print coroutine dot status, and here we can like say, let's say we want routine status of 1. And here it actually gives you a nice what status is in VS Code. So here we can see we have running, and this is just if the program is currently running. Is that coroutine running? Is it busy working? And you'll get this. Suspended is if the suspended is if the coroutine is not running. So if it's kind of stopped or it just hasn't started yet, then you'll get suspended. Normal is if it's active but not actually running. And dead is basically if it has completed or stopped with an error. So you can actually go to the documents here, so you can just do documents. I'm not going to be doing that, but you can if you want to know more about this. If we save this and we just lua our main file here, and then as you can see, we actually go to run. We should probably just do that, and then we can do this. My bad. And yeah, as you can see, we get that. Just don't add curly brackets here at the end. It should be without it. So yeah, then we get suspended because this hasn't even started yet. But what we can do is we can say coroutine dot resume, and this will start or resume a coroutine. So it can do both. And here we can just pass in the routine. So I'm going to say routine 1, and let's see what we get. We get routine 1, and it only goes up to 5. Even though we said it should go up to 10. Whoops, we can then this. Okay. So even though we said it should go up to 10, we get 5 because we yielded it. It's actually waiting for another one to execute. But it still says suspended here. That's because it's not running. If it's not running, then it's suspended. But what we can do is we can then go like this. And we can copy this. So what we're saying is, take this first coroutine and start it. and then we're printing out the status of it after it has gone up until I equal 5. Then we're saying, okay, resume it, continue with it, even though we said yield, and then we're printing out the status. So let's see, and now it gets suspended, and it continues, and then we get dead, because it has completed, it doesn't need to continue anymore. So this is one example of how you can do it. If you want to actually see it in action as running, then what we can do is we can take this print right here, and I'm going to put it right here, right underneath this. It can't actually access itself, so the way we can get this to access itself is to just make this global. Now if we were to run this, as you can see, we get the running status after each one until it says dead. So that's how you can just check if it's running. So I'm just going to go back to our previous example here. Again, here we go. Now, the reason why coroutines can actually be quite useful is, let's say we take this and we just create a copy of that line and we make that 2. Now look what happens. I'm just going to remove that status right there. So look what happens if we just clear that and run it. We get routine 1 up until 5. And then we get routine 2 actually going to until 20, and then routine 1 is continuing. This is why it's useful, because you can actually stop the routine in its tracks and let another routine run. You can think of it as a loading bar. Let's say you're installing a game and you're seeing that loading bar right there. And let's say routine 1 is the main routine. And you can make that yield until, and let's say it extracts the file. And that could be routine 2. Once it has extracted the file, your loading bar would go a little bit up. And then, let's say now it has to put that extracted data into its folder location. I know this sounds like gibberish, but we can actually take a good look at this by, if we were to open up my file manager here, and just copy a large file. So I'm just going to copy a big anime file, and the big one should probably be Demon Slayer. We can then create a new document, or go into documents and just paste it here. And we should actually see a little, and here we go. You can imagine this as a coroutine. For each file it has copied, or for each megabyte it has copied, the coroutine gets yielded, and this moves up. You can imagine it like that. So yeah, that is one way to imagine it. It may be a little confusing, but if you actually work with it, it does become less confusing. Anyhow, before we finish it off, one thing we can do is also check if a coroutine is currently in a specific state. For example, let's say we don't actually know if coroutine 1 has completed. What we can do is we can go here and say if coroutine.status, and we just put in the status of this routine, or we didn't put in a status, we just put in the routine, so routine 1, if that is equal to, and it actually completes it here for me, I'm going to say suspended, then, so only if it is suspended, should we try to resume that coroutine, like that. Let's see what happens. And there we go. That is all for today. It's just about coroutines and how you can use them to basically stop a function in its tracks and then run a different function whilst that first function is still waiting. And once the first function has completed waiting, you can make it run again, and you can check its statuses and use that to your advantage. And that is coroutines. Today we'll be learning how to work after reading files and writing to them. So there are 2 ways we can do both of these. And I'm going to start off with the most simplest way possible, the most straightforward, is just you do and it's done type of way. So currently, if I were to go here, these are all the files in the current folder. I don't know, I should probably open up a file manager so you can see them. I go to documents, and I go to trash folder, and to my Lua folder, and there we go. So that's all there is inside of it, just a Lua file, just one Lua file. So let's create an file. So to do that, the most basic way is to just go io.output, and this basically means input output and then dot output. This is going to create a file, and if the file already exists, it's going to empty the file. So we'll see what that means in a second. So let's go here and say myfile.txt, right? So this will also select the file. So if you're selecting a file, or if you're working with files, then this one will also select the file for you so you can work with that file. That is why the following piece of code, io.write, will work without a problem, because we have selected that file with io.output. We have said we want to output to that file. Here we can then say something like hello world, right? And then io.close, and this will close the file. It's highly recommended that you do close files after you're working with them, because not closing a file could cause some leaks in your program, which you don't usually want. So maybe you're trying to write to a file again and you forgot to close it. You might get an error trying to write to that file because the file was never closed. Anyhow, we can save that. And now if we were to run this, so Lua and then name it Lua, then as you can see here is in myfile.txt, and if I bring this up, myfile.txt. So this is just everything that's inside of this folder right here. So I'm going to close that. We can then open this, and inside of it there is a hello world. Pretty cool. Now to show you what I mean by it will empty the file is if I were to go here and add let's say a hello world with exclamation mark this time. Save it, run the program. Now if I open up this file, the previous hello world is gone, but this time there's a new hello world with an exclamation mark. So whatever you put in here will overwrite the file. So you should only use this if you're creating a new file or if you're emptying a file. Maybe you have a specific save file. Quickly io output, io write, io close. Done. So that is when you would use that. Now let's say we want to read from the file. Reading from the file is rather simple. So we can keep this io.close here, and we can just say io.input this time. And this will get input from the file, so it will read the file, in this case myfile.txt right there. And then io.read, and this will read the file. And we can just save that inside of a variable, so local file is equal to that. And here we don't put text. Here there's something special we can put in here. So there are a few things. Let's start with a number. So let's say we put a number in here, for example 5. This will read 5 characters. So I'm just going to go here and say print file, so you can actually see what's happening. So it only read 5 characters, so only the first 5 characters, which would be hello, and in this case it says hello world. So if we were to say only 2 characters, save it, and now we're reading 2 characters. If we were to say 100 characters, and we know it doesn't have that many characters because it's just hello world, it will just read everything then. So you don't have to worry about that too much. So that's the first thing you can do. The next thing you can do is you can go here and say in quotation marks star and then number, and this will read a number. Currently we don't have a number in here, so I'm just quickly going to put an 88 in here, save, and then go here, save, run it, and we get 88. So if we try to say file plus 99, let's see if that will do anything. And as you can see, because we read it as a number, it went up to 187 because we added 99 to it. So that's to specifically read it as a number. You could also do it by putting a number in here, and that will also allow a number read, so it will still give you 187.0, because remember, Lua doesn't really work with types, so it will automatically get numbers. But in this case, for example, if we were to say S there at the end, now if we were to run this, then we'll get an error. And if we were to say here number instead, then it will still work, because it will only read the number, it will not read that S. So that is why a number can be very useful. So if there is any other text in there, you can just use number. Anyhow, so let's put hello world back in here. And in here we can just say start line, and this will read a line. So if I were to just remove that at the end and run this file, then we get hello world. If we were to add another line here, and we can make this hello Jack this time. If we were to then run this, then we'll get hello world. If you were to do this, and let's actually just put i.read in here. I believe that would be the easiest way to go about this. I don't have to do that, I can just do this. And I can comment that out, and I can say cb. Let's see what will happen then. First it reads hello world, and then it reads hello Jack. So by saying i.read and then star line, this will move down the line after it has read that line. So if we were to do this again, we don't have another line to be read, so we'll receive nil. So yeah, that is how you can read multiple lines at once. So let's remove these, and we can actually just go back to the original setup here. Cool. And then last but not least, we also have all, and this will just read the entire file. It won't care about lines or numbers, just read the entire file and return it to us. So that's the most basic version of reading and writing to a file. So we can stay with this, and we don't need that io.input anymore. So we can remove that. Now this local file, we are going to say io.open instead. So this will open the file. Then we need to specify the file, so in this case my file. And they want to specify the action we want to use on it. In this case we can, let's say, W. So this will mean write. As you can see here, there is read mode, write mode, append mode, and we can probably move down. Yes. W plus, update mode, all previous data is erased, and you can just go read through all of these. I'm just going to cover the most basic. So in this case, that will be write mode. And remember to always have your close here, but in this case we can't use io.close anymore. We can use file, colon, close, and this will close the file. So that's our new way of doing things. It's file and then colon. Now in this case we want to say, and here, file, colon, write, and this will write to the file. My name is Netsu. Save it, and if we were to run this, it will write to that file. And I forgot to put a .txt here, so it created a file as well. So we can just delete that file. So if the file doesn't exist, it will create it as well. Save it, and now if we do this, it will have rewritten this, and now it's my name is Netsu. So it will overwrite it, just keep that as note. Yeah, so that's how you can write to a file. Next up, if you want to append to a file, you can say A. So if let's just rewrite this file. Okay, so now it says my name is Netsu. Cool. Now if you want to append to the file, you can use A, and that will append the text. So it won't overwrite the file. Like up until now, we can only overwrite the file. We can't add to the file. So this will allow us to add to the file. And in this case, let's say I'm going to add a /n so it can go to the new line, to the next line, because currently if I add to it, it will add to the back here. I want it to add to the bottom of this. So I'm going to create a new line. And I'm going to say Jack, he is old. And then let's put a little bit of dialogue here. And then here we can say Netsu. Yeah, I know. Cool. Say that if we were to run this file, then now we'll see this. My name's Netsu, and then Jack, he is old. Netsu, yeah, I know. And we can add to that. If we were to run this again, if we were to run the file again, as you can see, it gets added again. If we do it again, it just gets added to the bottom. So A is for appending and W is for writing. So it'll overwrite it. W won't overwrite it if it's A. So it's append. Next we have R for read. So this will read the file. In this case, we don't use file.write here. We use file.read, and we don't have to put anything in here. That like this. So it works the same as before. We have our same arguments. We have our star all for all. We have our line for a line. We have our number for a number. It's up to you which you use. Depending on the scenario, you might use something else. Anyhow, I'm going to say star and just all because I want to get everything. I'm going to store this in a variable. Local red is, let's just go with red so it doesn't mess with anything. And here, after a file has been closed, you can do this before the file has been closed. I just do it after because why not? Do that. If you run now, we get everything that's inside of it. Only once a line, then of course you can say line here. Now if you were to run it, now you get only one line. Today we'll be covering the OS module, the operating system module. And the OS module allows us to work with the operating system, as it kind of suggests. Now, some of the things that the operating system can provide us is maybe the time our code takes to execute, or maybe the time since 1970. It will also allow us to get environment variables, which we'll be getting to what that is, and execute commands from the terminal, but not from the terminal, from Lua. Remove and rename files and stuff like that. I will be covering everything. However, if you do want to know more about the OS module, because it is an amazing module in any programming language, then you can probably just go check up for the Lua's documentation and you should be able to find quite a lot of interesting things you can do with it. Perfect, now let's get started. So first, let's try and